AirDrop starts with one of three discovery mechanisms, at least per Apple's documentation.
And today we have our guest Eva Santos.
Eva takes us behind the scenes of how peer-to-peer protocols work over Wi-Fi.
That's a story where the OWL project that reverse engineered AWDL. Can you share a bit about the story behind why did they reverse engineer AWDL?
I don't know why they did it per se, but essentially the problem was in the mid 2010s, we had a situation where we had these casting protocols that were used everywhere, but I don't think anyone actually understood how they worked underneath.
In peer-to-peer mode, so are those frames encrypted, and if yes, do they follow like the standard security mechanisms that are there in Wi-Fi, like WPA2, WPA3?
The AWDL frames themselves, the parts that I was looking at for the parameters, at least capturing, I was able to see everything. Now, per Apple, I believe Airplay is encrypted with AES for the sensitive data things.
Given the impact of casting on Wi-Fi networks, what are some best practices or recommendations that you would give in order to make a good Wi-Fi design?
Yeah, so what I would say is be very careful about what you're doing with multicast, because multicast, it works almost too well.
Hey everyone, welcome to Weekly Wi-Fi Wisdom podcast series, where we talk everything about Wi-Fi and the tech that surrounds it. I'm your host Sainath. I'm WLAN QA engineer at Candela Technologies, and today we have our guest Eva Santos. She is currently working as a support engineer at Meter. And if you are on LinkedIn and if you are following Wi-Fi for a while, I'm pretty sure that you have come across Eva because she has been spreading many technical aspects of Wi-Fi on LinkedIn, helping the community. So I'm really grateful that Eva joined us today on our podcast. And today she is going to talk about casting protocols. Welcome, Eva. How are you doing?
Pretty good. How about yourself?
Yeah, I'm doing good. Thank you. So let's get started. So when we talk about casting, we hear a lot of casting protocols out there like Apple Airplay or Google Chromecast and many others. So could you please give us a broad overview of how these protocols compare to each other? What are the similarities or differences?
Yeah, so at a base level, a Wi-Fi peer-to-peer network, or what we would call peer-to-peer in the base 802.11 standard, it's really just a independent basic service set. So the 2DS and the from DS bits will be adjusted so that we know that they're both set to 0. So that's essentially at its most basic a peer-to-peer network. As the industry has developed, things have come along from the Wi-Fi line, such as Wi-Fi Direct, Wi-Fi protected setup, where we start to see an attempt to standardize some of these peer-to-peer mechanisms. And then came along some other attempts from the Wi-Fi line, such as Miracast, which really isn't for data. It's strictly for screen mirroring type functions. Sure, there's some other things, but then the companies themselves that make these products started developing their own protocols. I think Chromecast does their own proprietary protocol to some extent, maybe not anymore, but I'm not quite sure. But most notably, there's Airplay, which is probably the most used that I've come across. And a lot of these proprietary casting protocols built on top of the base standards by also allowing for data transfer type activities. So, for example, for AirDrop. So at a high level, I'd say those are the major differences between some of the protocols we've seen.
Yeah, I think that's a great overview. Now, from a user perspective, it, it it is seamless, right? The user can hit screencast or AirDrop, and the thing happens. But from a technical standpoint, what are the steps involved, right from discovery of the two devices to actually screencasting? So what are the stages?
So, for airdrop in particular, or just in general, I guess I could talk about airdrop since that's probably what people are most familiar with. So, airdrop starts with one of three discovery mechanisms, at least per Apple's documentation. The first of which could be a Bluetooth Low Energy advertisement. So something like a TV will advertise, and in the payload of the frame, there'll be the IP address of the TV, and that's one way devices can discover each other. Another way people in the wireless LAN space are probably most familiar with is multicast. So they will use Bonjour to discover each other and join multicast groups and discover each other that way. The last of which is what I would consider the peer-to-peer functionality of using channel 149 in most circumstances to discover each other. So I because the documentation on exactly when these mechanisms are used isn't completely available, I'm sort of just guessing based on the documentation out there and some of the work that's already been done. But from there, once the devices actually discover each other over one of those mechanisms, then they will use AWDL to start and synchronize the data transfer, but the data isn't actually transferred. It's just for synchronization of the video frames and the channel maps that it uses and other parameters it needs to know. The actual data transfer can either happen over the channel 149 that AWL or 44, or I think it uses channel 6 as well, and 2.4. One of those channels will be used for data transfer potentially, but it can also use data transfer over whatever channel the AP is using at the time. Now, I haven't done a lot of experimentation on when it decides to use what channels for transfer, but it seems to potentially use a combination of the two. I've mostly seen if there's an AP involved that it uses the AP channel. You'll just see TOS data frames, destined to the MAC addresses of the clients involved.
Right. You mentioned AWDL. So I've come across a story, and this is from online reading. There's a story where the OWL project that reverse engineered AWDL. Uh, can you share a bit about that? About the story behind why did they reverse engineer AWDL?
Yeah, so it was some researchers from TU Darmstadt. I think that's the name of the university. And I don't know the why they did it per se, but essentially the problem was in the mid 2010s, we had a situation where we had these casting protocols that were used everywhere, but I don't think anyone actually understood how they worked underneath. So what they did was they ran a series of, experiments testing different things, capturing on channels, and they managed to reverse engineer how AWDL worked. And once they did that, they then developed a Linux library to make Linux devices compatible with AWDL and therefore Airplay and AirDrop.
Can work with Linux devices
Yeah,
if they reverse engineer.
I can find the link. Yeah, so once they reverse engineered it, they actually published on GitHub. I don't know if I can share the link here, but uh, yeah, it's out there on GitHub. It's Open Wireless Link. That's the name of it.
Sure. Now we'll go through that. So far the caching protocols that we have talked about are P2P mode, peer to peer. But are there any caching protocols that also uses the AP in between, like in the traditional BSS configuration? And if yes, how do they both compare? The traditional with access point and without access point in peer to peer mode. Is there any major difference in terms of performance?
So for the actual synchronization, I think mostly these protocols if they use the AP in the middle, it's mostly for discovery functions, um, or data transfer in the case of AirPlay. Now, I know there's some things out there like Wi-Fi Direct and Miracast, but I want to say those maybe don't use the AP in the middle, but I would have to like go try it out myself. Because the thing that I've come across is even though, for example, I have like an iPhone or I have got an old Samsung phone that I've been trying to test with, it's kind of hard to tell which protocol a device is using. And I've had to like go on the Wi-Fi Alliance product finder website to figure out which device does what protocol with their standards and then try and figure out, okay, what channel do I actually need to capture on? And that's actually been quite a bit of a struggle for me. I'm not like a professional QA person, so maybe there's a bit of a learning curve there. But because of that, I feel I'm a bit behind in actually trying to understand how some of the non-AirPlay things work because I don't have as many as though of those devices.
Yeah. Now let's talk about the security side of things, right? So in peer-to-peer mode, are those frames encrypted? And if yes, do they follow like the standard security mechanisms that are there in Wi-Fi, like WPA2, WPA3? How does security work in this peer-to-peer context?
Yeah, so if in the circumstances where I've seen the QoS data frames transferred through the AP, it will be encrypted as you would expect with probably a WPA suite of some kind or, enterprise, pre-shared key, whichever the case may be. The AWDL frames themselves, the parts that I was looking at for the parameters, at least capturing, I was able to see everything. Now, per Apple, I believe AirPlay is encrypted with AES for the sensitive data things, but as far as what's encrypted and why, and if it's just peer-to-peer over, let's say, a non-AP station channel, that would probably be a scenario where it just uses AES of some kind for the data payload itself. Now, I can tell you when I was looking at the BLE IP advertisements that, for example, a TV might send, in this case, I think it was my phone sending the advertisements. Those were encrypted, at least the Apple products. And that, I believe, uses AES to encrypt it. I think it's one of the two options for BLE, but yeah, that's what I've observed so far.
Right. So there are, as we are talking, like there are many different casting mechanisms. So for Apple, it's Airplay. For Google, it's Chromecast, and maybe Amazon has Fire TV Stick. Uh, so how do these ecosystems compare with each other? What did you find the best in terms of be it reliability or performance? Which of them are doing better?
Yeah, so admittedly, my observations come from either the small amount of testing that I've done at home within my household or things I've seen out in the field. To be honest with you, I only deal with majority Apple environments at my really, really large sites. Therefore, if I do see a problem, I think there's some level of bias that it's always AirPlay that I'm trying to troubleshoot. Maybe if I had sites in other places where it wasn't a predominantly Apple market, I would have more to say on the compatibility for non-AirPlay casting protocols. What I will say is in the research that they did at TU Darmstadt, that that they found that the performance is fairly good. That the problem is just the interoperability aspect of it. Probably. I mean, I can't speak on behalf of the researchers, but the general movement in the industry had been Apple developed this AWL protocol that allegedly has better performance, but it's proprietary. So I think they actually had some involvement in the Wi-Fi aware development to try and make something that the rest of the industry could use. But I don't know the specific details, and it could just be hearsay. So I don't want to, misspeak on behalf of other parties, if that makes sense.
Sure. Yeah, I think that makes sense from whatever viewpoint that you had. Um, yeah, the majority is Apple AirPlay. Maybe it's due to its popularity with iPhones. So, have you come across any scenarios where casting has failed? Did not work as expected due to heavy interference or things like that. So, under what circumstances do you see these casting protocols fail?
Yeah, so I've had one or two scenarios where we had APs or a particularly high amount of background interference on channels 149, and specifically it's 149 at 40 megahertz width. So that would be 149 and 153. So if we see on either of those channels that there's already a lot of incumbent you know, devices using that channel, that might be one scenario where we see AirPlay take a performance hit. The other scenarios where I've seen AirPlay, that most of the problems I've seen with AirPlay either are related to mismatching OS versions, or for example, someone will see like on their phone that there's too many TVs that they don't expect listed, or the TV that they're looking for isn't listed. And in most enterprise infrastructure situations, that's usually a multicast problem, because that seems to be the primary mechanism that they use to discover the other devices. So those are the main problems. It's kind of rare. Like once AirPlay is working, it is rare for me to see the actual stream itself have a problem. It's mostly in that discovery process that I see the most problems.
Yeah. Um, Now, given the impact of casting on Wi-Fi networks, what are some best practices or recommendations that you would give in order to make a good Wi-Fi design, putting these casting protocols in mind?
Yeah, so uh are you do you want to know like design best practice or like configuration best practice, or both?
Yeah, probably we can go with both. Uh, we can go with both. I mean, good practices where a network admin should consider these casting protocols, take them into account so that the existing Wi-Fi network do not take any performance hit.
Yeah, so what I would say is be very careful about what you're doing with multicast, because multicast, it works almost too well. And if you, for example, have a TV on one VLAN and your client device is on a different VLAN, and you need to get them to communicate with each other over a multicast, if you sort of willy-nilly enable multicast to route to those VLANs and flood each VLAN, you may end up with a lot more multicast traffic than you intend to. Now, I would look and see if your vendor has features such as multicast to unicast conversion, IGMP snooping, anything you can do to control that multicast traffic, because especially the more devices you have, for example, like the MacBook I have here will send out MDS traffic, every now and again, just for that discovery mechanism. So if you multiply that by 2 or 300, that ends up being a lot of traffic just ambiently filling the airwaves. So it can really damage Wi-Fi performance in particular. So that's one aspect of it. The other I would say is specifically for these maybe AirPlay and Wi-Fi where they tend to use the same channels as far as I know. AirPlay will use 149 at 40 megahertz in the US. In the EU, that I think that's channel 44. I haven't tried it, but um, be aware of what channels those casting protocols might use if you are predominantly in that environment. So, for example, you're completely an Apple TV shop, or you're completely a Samsung TV shop. Be aware of those channels that they use for the peer-to-peer connectivity or data transfer, and make sure. I don't know if I would necessarily remove them, depending on what you're doing, because it might not all go over the air. But just be aware of it and how using those specific channels can impact your design. Because, like I said, I've seen before that if there's interference or a lot of traffic on a particular channel that the streaming protocol uses, it can impact performance. So I'd say those are the two most important things.
Right. There is this Wi-Fi is evolving, right, with things like Wi-Fi Direct and I think Wi-Fi Aware 4.0 is called Wi-Fi Direct. So, do you see this kind of standardization helps in enabling better interoperability across different ecosystems?
Well, I certainly think having some level of interoperability wouldn't hurt. Whether I want that interoperability to come from, for example, in the case of Wi-Fi ware is mostly through EU government action saying if Apple wants to operate in the EU, they need to follow our rules for interoperability and make sure that it can sort of live and thrive in our device ecosystem. So I'm not sure I want it to result from those mechanisms in particular, but it is a problem when we, as people trying to troubleshoot these protocols, even though that people, for example, from TU Darmstadt went and tried to reverse engineer them, there's still a lot of mystery over how some of them work and what we need to do as people to support them. So from that perspective, I do wish there was a bit more transparency. And I think if we move towards mostly a Wi-Fi alliance driven development, we'll probably see more of that. For example, with WPA and other things that they've done to promote interoperability in the device ecosystem.
So this is about future outlook. So do you anticipate any kind of features or enhancements from these casting protocols so that they make the existing experience better?
Yeah, so from what I've read about Wi-Fi aware, I think to some extent it can use some level of like 802.11 AZ or MC, like a localized location measurement. So I think that might be the next step, maybe to know proximity of devices for these peer-to-peer type functions. I think they're used to some extent, but I'm not sure to what, or, it might just be a thing that's in the standard, but maybe not commercially developed as much. So that's one thing. I guess another thing, maybe we'll see some developments with security and maybe performance related, for example, with some of the improvements to Wi-Fi 7 for performance, maybe like an MLO kind of thing. That there was an article out there, I think from what was it called? Ditto. Well, it was some technical blog that speculated on what they might bring to Wi-Fi Wear 5.0 eventually, and those were some of the improvements that they mentioned there that could happen. But honestly, you could put anything, in the standard or the operability document, but it's just up to the commercial industry to see, okay, what actually works for us to implement, if that makes sense.
Right. And do you see anywhere in the future these different caching protocols, maybe even proprietary ones from Apple or Google, converging them and um, getting into one place, open, standardized, maybe even integrating into IEEE spec, for example? Do you see that happening, or will we continue with these proprietary kind of implementations?
Honestly, in the short term, I still see it mixed between a standardized Wi-Fi Wear type situation versus a proprietary Google Cast, which used to be Chromecast, and AirPlay type situation. And the reason for that is even in the scenarios where Apple has said, "Hey, we're going to support Wi-Fi Wear," I believe it's only for iOS and iPad OS per their documentation out on their developer website. So if I use my MacBook right now and update it to the latest OS version, it will probably still be using AirPlay. So I think there will be some movements towards interoperability. I know the Android stack tends to use Wi-Fi aware as far as I'm concerned, and maybe specific things like Google Cast will still have some layer of proprietary functionality. So as far as I see for the next couple of years, I expect it to be pretty well mixed.
Uh, Understood. So I think we are done with the questions. So if you have anything to address for audience who are eager to learn about these caching protocols, you can address our audience, maybe who are looking for some good references. You can put them out. Uh, you can address, and then
Yeah,
after that
certainly.
conclude. Yeah.
Yeah, so what I would say is, especially if you work in a school district or office space that uses a lot of casting protocols, I mean, really the only way I've been able to learn is just getting hands-on and taking lots of packet captures. I even got a BLE card to see what might be happening over the air for those IP advertisements. So I'd say for Airplay in particular, there's a lot of good Apple specific tools from either their developer resources or from the MacBook console. I think those have been the biggest things that have allowed me to understand how it works and what it's actually doing. And for the other ones, I don't have as much exposure to them, but I guess my one wish to the industry was I wish it was easier to figure out which one of these protocols, if they're not Apple devices, that they're using, because I'm pretty sure Samsung does this thing called Smart View that is their own proprietary type of thing that's built on top of maybe another industry protocol. I just wish it was more transparent because more and more people depend on casting features, and it's something kind of like Wi-Fi in general. They just expect it to work, but when it breaks, it's so much legwork to figure out what might be breaking at the protocol level. So I'd say that's my one big wish from people, is that I just wish it was easier to get the resources to learn how they work. But yeah, that's my 2 cents. I feel that the casting protocols have just been underestimated for a long time. It's only recently that I've just been picking them apart because I'm like, okay, somebody's got to try and understand how they work. So, yeah, I'd say we'll probably see more interesting things with Wi-Fi Ware adoption in the Apple ecosystem. And as soon as I learn something, there's a new thing that comes out that I have to go and figure out. So yeah, it's definitely an interesting space to be in, I say.
Thank you for joining the episode and sharing all these insights. So somebody who is learning these caching protocols would definitely have gotten benefited from all your experience that you have shared with us. So thank you for joining and thank you for giving us your time.
Yeah, sure, absolutely.